I've also got to hold the microphone as well while navigating through the computer. So I'll give it my best shot. And I thought as well for my first, I'm not going to say proper presentation, but presentations in the company of such esteemed folks, I try and do a complicated live demo so I could really trip myself up. Okay, so my name's Ben, and I mostly work on free and open source projects and tutorials, trying to encourage people to make and develop, encourage a maker hacker community into Bitcoin. I noticed that when I went to Chaos Communication Congress in Leipzig in Germany, which is an event where 20,000 hackers defend on Leipzig in Germany, there's a sort of a distinct lack of interest from them in Bitcoin, because they see Bitcoin kind of in a certain light. So I wanted to try and dispel that and say, look, you can integrate the ability to be able to send transactions very fast through a network. You can integrate that into the systems which you're working in as well. And then also, myself and a couple of others like Justin Moon and Stefan Snygrov were just quite keen on trying to develop interest on people, experimenting and building DIY projects, mostly based on the ESP. Right, most of my projects are based on a small microcontroller called an ESP32. It's about $4, and it has the ability to do HTTPS requests. It's quite a powerful little device. You can run a web server from it, and then it's very low powered as well, so it has some great functionality, like you can put it into a deep sleep where it doesn't use any power. So it's affordable and powerful enough to be able to connect to an LND node or a Lightning node. So these are on the World Crypto Network. I have about sort of 30 tutorials now which I've developed. And I'm just encouraging people to try and get involved and try and to start experimenting. One of the benefits of working on these little devices is it's very rewarding to have, it's almost like a bridge from our digital world into our real world of things. So I named the series BTCIoT. So yeah, I think we all know where this quote's from. In the 1950s, dystopian writers would write about a future where state would put surveillance equipment in every room of every house. And something they didn't predict is that that's happened, except we paid for that surveillance equipment and then volunteered that information. But then, as Hal Finney said, the computer can be used as a tool to liberate and protect our people rather than control them. So I'm just going to skim through some of the projects which I've been working on, and then urge anyone if they get interested to try and get involved and maybe try and make some of the projects. So the first thing I wanted to do was start small with something which people might find useful. And I worked on something called, which is now gone, so let's see if I can get him back up. Let me see if I can get this back up, sorry about this. Bear with me. So yeah, all the projects are on my GitHub, ArcBTC, and the first one which I worked on was something called, where is he? It's a panic alarm. If anyone can see it. Oh, goodness me. Fake wallet, there we are. Right, so the idea was to create something which you could make look like a fake hardware wallet, and then if assailants came in and then forced you to plug in your hardware wallet, it would send a distress call. So all it does is send a post request to a Telegram group, which you could put some friends on and say, help, my Bitcoin stash is being attacked. But then you could also, if you attached a little button to it, when you press that button, it then turns the device on, and you could just use it as a panic alarm type button, or you could rig it to a safe, so if someone gets you to go in the safe, then you could try and trigger this panic button, and it would just message a Telegram group with your friends on. So it's just getting people to experiment with connecting it to an API and then doing a post request, and that's obviously through Telegram. So from there, I took I noticed when I went to the hack days, so I went to the Lightning hack days, and a lot of people were embedding Lightning full nodes into devices to try and get them to accept Bitcoin. And I thought, well, it makes more sense if that device is a slave device and your node is somewhere safe and secure, So I made a sweep machine where I had an ESP32, and then I just attached a tiny little screen. And instead of making a post request to Telegram, I just made a post request to the node, requested an invoice, and then checked to see if the invoice has been paid. Once the invoice has been paid, it then just spits out the sweets. So that was quite a cool little project. And then from there, because one of the benefits of these things is they have a whole bunch of GPIO pins you can attach modules onto. From there, I attached a little keypad, which meant that people could input an amount, press the hashtag, and then it would go and fetch an invoice and display the invoice, and they have a point of sale terminal, which I call the flux capacitor because it kind of looked a bit 80s. That kind of evolved into, they're all muddled up, into something called the M5 Stack Sats, which is this unit here. So this has an ESP32 built into it. It's developed by a company called M5 Stack. They're about sort of $60, and it comes in a nice kind of like, form factor case. So say if someone wants to have a point of sale unit to accept Bitcoin over Lightning, rather than have to build it themselves, then they could just buy one of these and then flash the code onto it. Christian Mutzel from the Raspberry Blitz project took one of these to Room 77 in Berlin, where Jorg has been accepted. He was the first bar in the world to accept Bitcoin, and he fell in love with the device because it works and it's functional. If I turn it on, it might even fire up and work. He fell in love with the device because he could just put this behind the bar, and then if there was a bar person there, and they can just input an amount, it converts it to Satoshis instantly, and then you press the hashtag, it goes and fetches an invoice, and then displays the invoice, which you can scan. So I wanted, that's a nice unit, but it costs like $60, and I think it's important that we remember that we are trying to, facilitate people be able to transfer in poorer countries where they don't have so many resources. So I wanted to extend that project into something which was DIY and somebody could do for cheap. So that's when I developed the quickening. So the quickening is the exact same hardware, a nice little TFT screen, except I managed to get the price of the project down to $8. So for $8, you could build this point-of-sale terminal. So someone in Venezuela, for example, could then build that point-of-sale terminal. And an important note, actually, the idea of retrofitting devices to be able to accept Bitcoin over Lightning, for us, we think, well, why don't we just use coins if we want to pay for something in a vending machine or pay for some sweets or something? But say if you live in a country where your currency is suffering from hyperinflation, that business model just won't work, whereas it actually becomes a feasible idea to have a vending machine in Venezuela with a small, one of these things plugged into it with a little screen, and then you can just wire it into the already existing mechanics of the machine to get it to spit out products. So it actually becomes like a functional, viable thing. And what's quite nice as well with these projects is it's been encouraging lots of people to develop things, and I've had lots of hitbacks on Twitter, people who developed their own point-of-sale terminal, or they've retrofitted a pinball machine to accept Bitcoin or something. So anyway, so it's not just all point-of-sale terminals. I also wanted to explore wider technologies which implicate Bitcoin. So obviously as Bitcoiners, we're into decentralized systems, and one of those decentralized systems we're quite interested in is mesh networking. And a company like GoTenor gets a lot of respect and time from us as Bitcoiners for good reason. But the only problem with something like GoTenor is it's not free and open source. It's not DIY, so you can't build it yourself. The units themselves are quite expensive, and also the bandwidth is very limited. So Espressif, whose who developed the actual microcontroller itself, they released a free and open source development framework, their mesh development framework, and with that you're able to get speeds of up to 10 megabytes, and they have a range of about 200 meters. Sorry, I've got a bit of a cold. They have a range of up to about 200 meters. But one of the benefits of it, though, is you don't need the GPIOs in such a unit. All you need is the actual microcontroller. And the microcontroller itself is $1 to $2 to buy. So very cheap. The idea being, I did this sort of tutorial series as a series of diaries. And the project itself is I live in a small village. It's about 2 miles squared. The project itself was to blanket the whole village in a sort of freely accessible network where you could download block data, which I could probably stream into the mesh through a satellite. So one of the other good things about these devices is they're so small you can embed them into something with a, sorry, one moment. So embed them into something with a power source. So something maybe like a light bulb, for example, and then have people put light bulbs in and around the village, and those light bulbs will then connect to each other and then create that service. So within the village, there would just be a hotspot they connect to called Bitcoin, they connect to it, and then they can just stream data for free. And then maybe even build a unicast layer where you could sort of send transactions through. But this is, I'm not a developer, I'm a hobbyist. And this is, I'm not a developer, I'm a hobbyist. This project's far too big for me, but I thought I'd try and, thank you so much. Yeah. That was much needed, thank you. Yeah, so I'm not a developer, I'm a hobbyist, so the idea was to try and get someone else excited in this project where they might start trying to develop this mesh network using these little ESP32s. I'm up to the second diary. I've got a third one in the works, and so far I've managed to send Bitcoin block data as it comes in across about 2 miles across a beach using a handful of these things. To blanket my whole village, it would probably cost me about £200 in just microcontrollers, and then I just have to retrofit them to light bulbs. Right, other things you can do with them as well, where these devices are used for, is drop gangs. So, because they're very cheap and you can send them to sleep and they don't consume any power, you can pre-program them with a whole list of destinations, location data with a picture in, and then you can get it to wake up every now and then, check to see if there's a Wi-Fi point with a certain name, and then if there is, it will then broadcast its own Wi-Fi access point, which someone could then log into, and it would tell them a location to go and pick something up from. And these are being used for drop gang scenarios around the world. So I thought that was quite interesting. And then, yeah, so I've also done some proof of concept ideas. So one of them was, I mean, this is incredibly tacky and simple looking device, but it's just got an NFC module behind it. So I could input the amount into the device, and then when I press the hashtag, it's listening for an NFC tap. I put the admin macaroon of my L&D node on an NFC card, and then I give the point of sale my admin macaroon, and it can go and make a withdrawal on my behalf. Obviously, that's a terrible idea, and it couldn't be used in the real world, but eventually we will have custom macaroons. And with a custom macaroon in L&D, you can add caveats. So you could have a caveat for only being able to spend up to £100 a day, under £30 transactions, you could charge that card with the macaroon, and then you've completely replicated our current tap and pay system with Lightning. And the user who's got the card with that macaroon, caveated macaroon attached, doesn't then have to have an internet signal in order to be able to make a transaction. So really looking forward to custom macaroons when this thing can kind of become a reality. And then just as if you lose your card, you phone your bank and you say, I've lost my card, and there's that security trade-off that someone might find it makes some transactions. There's only so much damage they can do, and the security trade-off for having the functionality of just being able to tap when you go into to buy something. I met with Stepan Snikarov in the Bitcoin conference, and we started talking out together because he's into these microcontrollers and hardware, and it's quite a lonely experience at the moment in Bitcoin, but we are starting to build something of a community. And I said, what I really want to do is get one of these things to become get a sort of DIY hardware wallet communities to start developing in Bitcoin. And he said, well, luckily enough, I've actually developed a Bitcoin library for Arduino. So by the end of the weekend then, we built a watch-only wallet, which uses a little e-paper screen. It has the master public key, and it means that you can, when we turn it on, it generates a new address, Bitcoin address, and then when you turn it off, the image remains on the e-paper screen, and you can take that around, you could use it for payments, and then when you plug it in again, you can refresh it and get a new address. This could, fairly easily, well, I say easily, but this could be developed then into a full Bitcoin hardware wallet. Obviously, it's got horrible security, but there are some security benefits. So the supply chain attack, these things are so generic, and they're used in so many different things that you kind of remove the supply chain effect problem. And there are some additional modules where you could probably store a private key effectively with it being somewhat secure. So yeah, Stepan's been working on another project called Spectre, which uses a similar kind of microcontroller system. And we hope to try and encourage a community of builders for hardware wallets. We should then, they might develop into businesses, and then we'll get cheaper hardware wallets. Those people in poorer countries with less resources can then afford to buy a hardware wallet. Or, if the shit hits the fan and we go post-apocalyptic, we could find those IoT devices with microcontrollers in, smash them, take the microcontrollers out and turn them into hardware wallets. So it could be quite a useful project. So what's this? Ellen, oh yeah. So I like innovation from the trenches, from people experimenting and making things, from people who probably aren't that experienced as coders, or people who want to be able to have something like Lightning Network work in a certain way and it doesn't yet work in that way. And there's a cool little community which has developed around something called LNURL, and this is the ability for your phone wallet to be able to do a GET request on your behalf and then fetch an invoice, for example. So what does that allow? It allows for, so in Lightning Network, one of our biggest problems is every time you generate an invoice, you need, every time you want to pay someone, you need to generate a new invoice. If you're making repeat payments for the same amount, this would allow a static QR code. So instead of my Sweet Machine having to have the display, you could have a static QR code and then just keep firing it with Bitcoin. Another area of friction in something like Lightning Network is if I want to sort of withdraw money. So if I use Lightning on an ATM, you have to have a camera to be able to show the QR code to you, and then you have to generate an invoice for the amount which tells you to generate the invoice for, and then you show the thing. Well, with LNURL, you're able to do that through this GET request system. So a couple of wallets have integrated it already. Blue Wallet's integrated it. The Bitcoin Lightning Wallet's integrated it. We've managed to convince Zap to start integrating it. So it's a really useful set of tools which lots of interesting projects will come from, I'm sure. But there's also an authentication component to LNURL, so you could use it for, like Lightning Network is, so I'm told, I haven't researched it too much, but is very good at kind of, proving identity with your wallet. So this sort of facilitates that as well. So I played around with that, and this is going to be my demo, which I'm going to fluff really badly. I played around with that, and I've made a little project called Mort. So in Mort, it's not that much code, just a little bit of code here. So you would literally just copy and paste this from the GitHub, and then flash one of these devices, which I'm actually going to do now, and then, let's see if this works, flash one of these devices, and then we can create a server which can respond and give an LNURL QR code. And if this works, then some of you out there will get a few free Satoshis, so hopefully that'll incentivize you to be patient. Okay, so this is just the Arduino, a bit of doxing, got my admin macaroon, or part of it. This is just the Arduino IDE, which is, it's made for hobbyists, and it's fairly easy to navigate. I plugged in my ESP32 into my computer. I'm going to connect to it over, I'm going to connect the board. I'm going to open up my serial monitor, so we've got a readout. I'm sure I won't do that just yet. I'm going to flash, so I've put in my credentials, so I've put in my Wi-Fi credentials to make sure this is connected to the right Wi-Fi, yep. I'm going to flash the device. And then something else which needs to be open, actually, is my Zap wallet. No, it doesn't need to be open, because, yeah. So the way this project works is so if you use one of the developing environments I'm quite interested in is just using a Zap desktop wallet. That creates a neutrino node, and it means you can develop without having to use a full node and exposing your full node to hacky, weird projects. So, oh, there we are. He wants to upload. So I'm going to hit the little button to let it upload. That's going to upload. I'll quickly blow my nose. Bear with me. Okay. I'll open up my serial monitor. Oh, something I do need to do is SSH out so the rest of the world can see this little web server which is running on here, because at the moment it's only running locally, which we don't want. So I'm going to do that. Then upload that again. We've got a serial monitor. Now, hopefully, if this works, please say it will, we should be able to claim some Satoshis from this. And you can see how LNURL works. It's quite a sweet system. So I'm going to use the Bitcoin Lightning wallet. There's our QR code there. I'm going to scan the QR code. I've spent the whole morning with this failing miserably, so if it works, it'll be a miracle. So it says, do you want your 100 Satoshis? I say OK. And then there you are. It generates an invoice. So it connects to my node, generates an invoice. The node pays for the invoice. And I've just received 100 Satoshis. Now, the cool thing about this is that's going to spit out 100 Satoshis every 20 seconds. So has anyone got Blue Wallet or Bitcoin Lightning Wallet on their phone? Go on then. Get your wallet out. Which one have you got? Blue Wallet, okay. You may get an error when you try and receive the funds. Just press OK to get past that. There's like a bad response or something, but it's fine. So if you click on Receive and then click on the Scan to Receive button on the thing. Has it worked? Yeah. Did you get the 100 Satoshis? Nice. Yeah, there we are. Cool. So, while I'm talking and showing you the rest of the presentation, I'll leave the QR code on the screen. And every, I think it's 10 seconds or 20 seconds, there's 100 Satoshis for grabs. So, go nuts. But I've limited it to every 10 seconds. Now, there are some problems playing around with some of this stuff, an LNURL. I put like a decimal point in the wrong place, and then ended up paying for one of these things, and then didn't actually claim through the QR code, and I ended up like losing like 50 quid or something. It was ridiculous, so it was quite embarrassing. Okay, so what I do with that? So from that, I made something called Physically Faucet. I can see people there claiming their 100 sats. So that's just, it's this, except instead of, so in the code for this project, when I make my QR code, I output it to the serial monitor on my computer, but I can just replace that line of code there, add a library for this little TFT screen, plug him in, and then that becomes a faucet. So I'm taking that to the Lightning conference. I've got one here which I can set up and put outside, and then it's just a way of people getting Satoshis so they can start playing around with Lightning Network, which is pretty cool. And then from there, I thought, well, okay, it's not a massive leap of the imagination to add a coin mechanism. So instead of me saying I want someone to be able to withdraw 100 Satoshis every 10 seconds, I say, count how many coins have been entered into the machine, and then take 2% off for me, and then make a withdrawal for X amount of Satoshis. And then that's an ATM, like a very simple ATM, which people can use loose change for. I did bring this, but I managed to break the little screen for it, so that's quite depressing. I didn't have a spare one, because I'm an idiot. But it's a very satisfying experience, and you all would have loved it, so it's a shame it's not here. But it was a cheap DIY project, and something which, so if you have again, you're in a scenario where you've got inflation problems, or people want a quick off-ramp from fiat change crap into something like Satoshis, then this can provide that off-ramp. And all the information on how to put this thing together is in the GitHub. It explains the process, and then the libraries you need to install, and then all the crazy wiring to make it work. So yeah, if you're interested in that, making your own ATM, then have a crack. Oh yeah, there it is. So is that it? I think that's about it. So my main emphasis, mine, Stepan Snigarov's, Justin Moon's, is we just want to create a sort of hacker-maker community within Bitcoin. So again, if the shit hits the fan, we can just get all this stuff and we can retrofit things to be able to accept Bitcoin. So it's a useful and valid proposition, I think. And then also, as well as that, when I go to Chaos Communication Congress and I'm with those 20,000 hackers, I want them to be as excited about Bitcoin as I am, and the ability on something like Lightning Network to be able to send microtransactions to turn stuff on or turn stuff off or whatever else. So hopefully some of you will go out and make these projects. If you have any questions or if you get stuck, hit me up on Twitter, at BTC Socialist, hit me up on Telegram, you can find me on there as well. I look forward to anyone creating projects or something which spin off this. I'm glad my little demo worked. Has anyone else claimed the Satoshis? No? Anyone else got Blue Wallet? Want to give it a go before I turn it down? No? All right, cool. All right, thank you very much. And cheers for that. Sorry about my runny nose. Cheers. Thanks, man. Cheers, Mindy. Brilliant, sorry. Did it work? I don't know.
Would anyone have questions, maybe? Yeah? Yeah? Coming.
Really great talk, really enjoyed it. I'm having a bit of a play with some of the stuff myself. I haven't really had the time to really get too involved. But just one question, what's your thoughts on Arduino versus MicroPython for this sort of stuff? Any advantages and disadvantages for either of those languages?
There's a lot of support, there's a lot of libraries for Arduino. MicroPython, I think it's just kind of like a Python-esque programming language, which actually then compiles into C. So within our, like Arduino, you can use C, you can use C++, and then you can use this sort of Arduino weird hybrid library thing, language as well. So I would just recommend not being scared of C and just going straight into C. There's a lot of, it's a very attractive idea being able to use Python, because obviously Python's good for teaching, but it's not too hard to kind of get your head around this. And particularly if I mean, it's been quite easy for me, because I can just look through the Arduino forums and tutorials and say, well, that's cool. Someone's used a coin mechanism. I can make that work for Bitcoin, So you can just do the similar. You can just go look through what people are making and then just retrofit it to accept Bitcoin. So no, I would just advise going for the Arduino, language.
Thank you.
Yeah. Anyone else have a question at all? No, cool. Thank you.